All right, everyone. So thank you very much for joining. My name is Matthias Lübken. I'm the PM for our Kubernetes support, which we launched earlier this year. We've been working on it for quite some time, and I'm really excited to share a little bit on our basic thinking here and where we're heading. Let's get this going. So. The basic thing is that Instana in general is that when looking at the microservices world in this play is that not very but very often, not very seldomly, you see something like this, right? You see an application that actually connects of very many services that talk to each other, that are connected, and it's actually quite dramatic in a sense of getting a sense of this all, right? Seeing what is happening, and this is the challenge, right? Is not you only, not we only, but many customers, many users out there, and this is where Instana is heading, right? We try to help people, customers using microservices in all sorts of different environments. Instana is actually a fairly young company. Founded by some, experts in the APM space. We do have our headquarters in the US, but development support, everything else is more or less globally at this point. And we're running good. We have many customers, many happy customers, and hope to get more. And when talking to these, right, in the last couple of years, to many of these that you see here, we realized, we saw that the Kubernetes is really taking off. And just before the call, I just did this Google Trend thing that you do, right? As you all know, Kubernetes is taking off, and we think or we know that this was important, so we try to do our best to put like really great Kubernetes support into our APM tool. Now, the challenge generally, what we see, in these microservices and container stack, is that these are getting more and more diverse, right? Deep technology stacks with on different levels, on different hosts, on different cloud systems, with different container technologies, with different languages, polyglot, with different databases. So the technology stacks get more and more diverse, and even more so, they get more and more changing, right? Even before the times of Kubernetes, things are changing. But the important piece to remember is that it's why these things keep changing, and you need to need to monitor that. The impact for the user is actually the thing that we should all take care most about. And the honest thing is that these interactions between the different services to the user actually are somewhat unpredictable. It's not always, things are changing constantly, so it's hard to keep track of it. When we are adding Kubernetes here, right, things are even getting more versatile and even more dynamic. That's where Instana comes into play. We think, this is an interesting topic to challenge. We try to do our best there, and we've got some core features that we think is really, really important. For one thing, we try to be as automatic as possible. So everything that you will see later from Kevin is, more or less automatic. The configuration is down to a minimum, and that's really important because things are so dynamic, all right? And there are so many things you need to take care of, or that part of your system. So the automatic thing is really, really important. The second one is that it's so dynamic, and we want to be, making sure that we know everything that is coming up and coming down. So dynamism is built into what we see. But last but not least, the whole thing, you need to make sense of it all. So we've got this little stand there that is like trying to make sure that you only see that information that is important to you, right? Right, with all the noise, with all the information that you'll see, especially in Kubernetes, especially in these event cluster systems, you will see so much information that we think it's crucial that you get some good machine learning on top of it, that only the relevant information is displayed to you. So long story short, Kubernetes is here. It's getting more and more sophisticated. It's getting more and more things are getting in there. And while you put your workflows on it, we try to make sure that only the information is just displayed to you that are relevant, that you get the alerts that are relevant. But when you want to dive into it, that all the information is available, that you can dive into the details, and that you have the full stack actually visible, from the service to the cluster to the middleware container host, whatever your deployment is about. So before I hand over to Kevin, right, this is like the rough boring sheet on what we support. We are trying to keep up with the Kubernetes environments. This is a status of July. So we try to support the latest 3 versions. And by the way, OpenShift is part of it, right? OpenShift is the deployment or the version from Kubernetes from Red Hat, and very popular within our customers. So we put some great effort here in there, so that we actually support also OpenShift. We are testing all sorts of different deployment ways of Kubernetes itself, right? So we have our just general custom deployment or like EC2 environment, but also managed versions like Google Container Engine and the version from Azure AKS. If you have a different cloud vendor and you want some native support, feel free to reach out. We're always looking for more ways and making doing the best we can so that you have a smooth experience. We have some dashboards and metrics and know-how on different parts of the system. I'm not going to go into the details. There's 2 links here where you can dive into all the details. And yes, that's basically it. So I'll hand it over to Kevin, and he'll show you what we can actually do with it.
All right, thank you, Matthias. I'll just wait for you to give me presenter mode, and I'll share my screen. So what I'll be going over today, well, first of all, thank you everyone for joining and taking time out of your day to view our webinar and to learn more about our support of Kubernetes. But what I'll be going over today is installing Kubernetes, or not installing Kubernetes, installing the Instana agent onto Kubernetes using our Helm chart. I'll be going over what is actually happening during that discovery process. It's very short, so I don't have a lot of time to get into technical detail, but I will explain how the agent is deployed and some of the inner functionality of it as it's discovering the Kubernetes cluster and our application that we're running on it. I will then go into a demonstration of the Kubernetes monitoring, what we do monitor, what we support, and I'll go through a few exercises of scaling out a service to the point where it actually is no longer scalable because we don't have resources, and I'll demonstrate how that is shown in the Instana UI and through our alerting engine. So I'll go ahead and get started with explaining, how we set up our Kubernetes cluster. This is a vanilla Kubernetes cluster running on Google Cloud Platform, their Kubernetes engine. Basic install uses RBAC, and once we have the cluster up and running, we'll go ahead and clone the Helm chart, which is available on GitHub. Once you clone that, you can deploy it fairly easily. So we'll go ahead and do that right now. We'll clone the chart. And then we will deploy it. So what you see here is a Helm install command. We're telling Helm install to pick up the Helm chart in the current directory. We're giving it a name. We're putting it in a namespace, and we are setting the agent key through a environment variable because I don't necessarily want to share that with the world. So we're also giving it a custom name so that we can filter it in the UI. Helps if I complete the command. So what we see here is that a few things got created. And while that's creating, I'll kind of touch on what the chart actually is doing. So we deploy Kubernetes, or we deploy Instana agent onto Kubernetes using a daemon set, which that means that it's going to run on every available node in your cluster. Within that daemon set definition, we're passing certain environment parameters to configure the zone, the endpoint, ports. One of the interesting thing to point out here is that we're actually creating a sidecar container, which helps our agent determine who is a leader for collecting information from the Kubernetes API. If we didn't do this, we would have, if you had a 40 node cluster, you'd have 40 nodes hammering on the Kubernetes API to gather information, and we don't necessarily want that. We only need one of our agents doing that work. And so that's what that sidecar is for, unless I'm incorrect about that, and Matthias can correct me if that's not the case. So I would imagine that at this point, we should see our Kubernetes cluster here. If we don't see it, there it is right there. So what I'm going to do is I'm going to go ahead and filter out everything else so that we're not seeing a bunch of other things. And I just want to point out, like, as soon as you click on any one of the nodes within the cluster, you're going to see a Kubernetes flyout where you can see that we do in fact have a Kubernetes cluster, and there's really nothing running in it right now other than the Kubernetes resources. So as you can see, we have a bunch of deployments here: Heapster, kubedns, metric server, and of course Tiller, which is the Helm component for deploying Helm packages. Now, as you can see here, we're collecting information about the entire cluster, including what type of memory resources, the pods, how many replicas are running, as well as what our nodes are, and percentages based on that. So now that we see that we have a Kubernetes cluster running and we're monitoring this, we're going to go ahead and start deploying some things to it. And what we're going to do is we're going to clone the robot shop, which Steve Waterworth, one of our marketing engineers, I don't know if that's an oxymoron, but he wrote a distributed microservice application in which we can deploy on many different infrastructures, Kubernetes, Swarm, Mesos, or DCOS, and probably something else I'm missing as well. So once we have that cloned, I do need to go in here and make a modification to the web service. And this is because this was mostly built for deploying on Minikube or a local Kubernetes cluster, and those don't necessarily have load balancers built into it. Whenever we're using something like GKE or AKS, those have managed load balancer services. So we're just going to change this to load balancer type so that it'll be assigned a endpoint within Google. So as you can see here, we have a bunch of deployment and service templates. I'm just going to do a simple for loop to create all of those. And as if we see here, we'll immediately begin seeing resources being allocated in our cluster. Things are starting to climb up, and we're not really anywhere near the capacity of our cluster with regards to the actual request. But what we are going to do here in a moment is we're going to demonstrate exceeding that, and then we'll see in the Instana UI that exceeding this. I'm not sure what the right word for that is, but we'll see that whenever we do exceed those limits, that we do get an alert about it, and we can actually determine what the problem is through the Instana UI. So while we're waiting for that to deploy, I'm going to see if we can get the endpoint for the web service so that I can start an artificial load against it. I can start doing a load generator. So it looks like we have the service running. I'm kind of curious as to why this isn't assigned a load balancer yet. It's possible because the pod hasn't been deployed quite yet. So that'll just take another moment or two. It's possible I may have, yeah, I don't think that's supposed to be in the selector. So that's why that didn't work. Let's see if I can. See if that'll.
You gotta love YAML, right?
I'm sorry?
You gotta love YAML.
Yeah, it's simple. 2 spaces makes a huge difference. So, okay, yeah, now we're creating the endpoint, the load balancer endpoint, which will give us the ability to talk to this application from the web, from, as an ingress point. So while we're waiting for that, I'll go ahead and scale up a service so we can see the actual deployment scaling. So if we close this, actually I want to go back into the dashboard. I'm going to go down to deployments, and we can see that we have 10 replicas now available for shipping, and we can see that bump happening right about the time that I did that scale. So obviously we had enough resources to allocate 10, so let's try and allocate 20 replicas and see what happens here. So you can see that there's unready pods. We have 18 available replicas, but we have 2 pending pods and 2 unscheduled pods. And if we come down here, in a short amount of time, we should see that this particular deployment becomes unhealthy because there are pods which simply couldn't be scheduled because we've run out of resources. And we can easily see that by seeing that we have a CPU capacity of 6. Our request is 5.7. We can't go above 6. So at this point, we have a, there we go. We switched to red just now, and we have an indication that we have a condition where the available replicas are less than our desired replicas, and we should be able to see here momentarily this unscheduled pod show up here as you can see it turned red. If we dig into this pod, we can see that this pod is not schedulable because there's insufficient CPU. So Instana is literally telling us what the problem is, and obviously, we can fix it by either adding an additional node to the cluster, or we can just simply scale back to 10 replicas. Now that kind of explains, just one of the alerting features that we have around Kubernetes. Some other things that we do monitor, and I can't necessarily replicate a failure right now, is for instance, if we bring up our Kubernetes cluster, say if etcd became unhealthy, the manager became unhealthy, or the scheduler, that would also raise an alert within Instana to let you know that there's an issue with the cluster health in general. So if we also, one of the things that is pretty interesting is how we've associated deployments pods back to the container and the cluster. So if we bring up this particular deployment and we open up the pod, we have a reference to the container that is running in that pod. And for instance, if this had 10 replicas, we would see all 10 containers here as well. So we're now in the container view. We're actually pretty deep into the view as far as what's available to us. We can dig into the process in the Node.js app. But for the container view, we can see here on the left that we have the association for the container within Kubernetes. So it's really easy if you're debugging or if you're looking through incidents, and the incident system will probably take you directly to the container or the application. You can easily back reference to the Kubernetes cluster that it's running on, the node, deployment pod, etc. And I think that's it as far as what I prepared to show you guys today. But we do want to open it up for questions. Feel free to ask any questions, and we will go through and answer those. All right, so if I can figure out how to actually view this, give me 1 second. All right, so Simon asked, if you install it like this, isn't it possible to get the API key back easily from Helm? My understanding, and correct me if I'm wrong, but we actually, Helm, we will inject that key into a secret, and I believe that kind of helps that that problem out because it's not readily visible in Helm, but you still can go dig into the secret if you have access and pull that out. Am I incorrect in that, Matthias?
No, it's exactly correct. We're using a built-in support from Kubernetes secrets, which is also Helm is leveraging here. So we're using here best practices to store the key.
Okay, so I could extract it. Why aren't you using K8 secrets? We are actually using K8 secrets, Simon. Unless I'm not reading this correctly, if you can see it on my screen. Is there support? David Schwalies asked, is there support for AKS in Azure? I actually just tested this out the other day. I built out a installing Instana with Helm on AKS, and yes, we do support it. It works fine. I didn't run into any issues, and I believe that while it isn't necessarily, Matthias, correct me if I'm wrong, we haven't officially announced AKS support, but it works, unless I'm completely unaware of something that doesn't.
No, it's exactly as you said. So it runs. We're doing our latest QA, so don't tell anyone, but go ahead and play around with it. We didn't see any problems around that. Speaking of Azure, we're planning to expand support there on other services. So it works on AKS, and you will see more on that.
Okay, fantastic. Well, does anybody else have any other questions? I think we have a few more minutes. Be happy to answer anything you got. Saibal, yes, we can. We will be sharing this video after it's recorded. Tom, do you have any kind of timeline on that?
Oh, everyone should receive an email in the next 24 hours with a link.
Okay, fantastic. All right, well, if there aren't any other questions, again, I want to thank everybody for attending and listening and learning a little bit more about our Kubernetes support. And if there's any other questions, feel free to reach out to. Not sure if there's a mechanism for feedback after this webinar, but if there is, you're more than welcome to do it, and we'll be happy to answer any other questions you have. With that, I'll turn it back over to Tom. Thank you.
Great. Thank you so much, Kevin. Thank you, Matthias. Great information. I hope that everyone enjoyed and learned a lot from the webinar. As Kevin just mentioned, if you have any feedback or suggestions on future webinars, feel free to drop us a line. You will get an email from us within the next 24 hours with a link to the recording. And please reply to that and let us know if any feedback on this particular webinar or suggestions for further ones. And I'll leave it there. Thanks so much for joining. Have a great day.